We start with a new project. Under Project, New Project. We select the path, Mapping Training, enter a name, or North, and adjust the resolution and scale of our project. Close the dialog with Apply. Okay. As next step, we stay in the project register to import a CAD file, which shall be the base of our image rectification. Under the node Drawings, we use right mouse click and CAD Drawing. In the path, we select the folder with our trainings examples. Under Mapping Training, Image Rectification, and here you can find the folder Church CAD Coordinates, and open the drawing file. We confirm the next dialog. On the left we have listed all layers of the CAD drawing and activate or deactivate them by choice. On the right in the preview we switch to the register drawing data and can see the drawing we wish to import. Above we can choose a measuring unit and afterwards check if the drawing size is correct. Sometimes different CAD systems work with different drawing units and you have to control if the import of the CAD file is accurate. We confirm with Apply and accept the paper size adjustment. You see our CAD drawing. If you wish to make any changes on it, you take a look at the project tree under the node Drawings, select the drawing, right mouse click and open the class management. Here we are presented with the same options as with the class management for mapping classes. You can switch CAD classes on and off as desired and change attributes like color or line width. Click on Adjust and the change will be applied on all CAD classes in this list. Apply. You can observe our changes in the drawing. For the next step we have to create an image layer for the coordinates necessary for the rectification. Under Auxiliary Layers you select Dimensioning Data Layers, right mouse click, New Dimensioning Data Layer and rename it Control Points. Now we can measure the coordinates needed for the rectification. In the first step we check if the object snap for the CAD drawing is really activated. We switch it on, because otherwise it would only catch elements of the mapping. Activated, the program catches the lines and points of our CAD drawing. We select the tool Catch Endpoints and measure now the first few reference points for the image rectification. Zoom on the door. Activate this function and you see the object snap mode. Go to the next line and select this point. Left mouse click and the program asks you for a point ID. We start with 1000. You can activate the display of the ID and change the control point's color. We measure another point. Take the edge of the windowsill. software assigns the following number automatically. And the other windowsill. You need at least 4 points for the image rectification as a minimum. Better are 5 or 6 reference points for the software to calculate the residual error for every point. With 4 points you have no error checking. So we have started with these points for the rectification of the first image. Now we switch to the register code rectification. Click on the node Coordinate Rectification. Right mouse click and onto Load several images. Folder Mapping Training. Image rectification. We find the example church CAD coordinates. Double click and we see all images of this object. With pressed Ctrl key, we select the first 4 images and pull them over to the right window section. Apply. The images are automatically integrated in the project. We save the project and open the first image with double click. You will notice the object points we first measured on our drawing are shown in the picture. The edges of the door, the windowsills and the room corner. We zoom in to start. In the toolbar we are given a couple of measure tools for control points to choose from. We start with Measure Natural Points. With pressed Shift K you can switch to the measure mode and a green crosshair cursor will appear. Now you can insert a control point with left mouse click. You are asked to insert a point ID. We start with 1000. On the right in the chart we have listed all control points taken in the project and in the CAD drawings. For easier working we deactivate the automatic zoom and return to the rectification and measure the next point. After measuring the first 2 points, the program starts to calculate the approximate position of all other points. And the last point, 1005. Okay. We have measured the 6 points and start the calculation of transformation parameters of our image rectification. And have a look on the register point errors. We have listed all points measured both in the image and CAD drawing. And you can see the residual error of each point. Unit is meter, meaning control point 1000 has an error of 4 to 6 mm. Another point has 12 mm or 8 and so on. This way you can check the quality of the rectification and switch on and off single points. Okay. We start the calculation of the parameters and then the image rectification. And with Transfer to Map, we integrate the rectification in our project. Our image is automatically positioned accordingly to its matching points in the CAD drawing. And in the project tree, Under image layer we see our image and can switch its display on and off. We measure further control points for the next image. If you have made a mistake, you can undo it with the respective function. Okay, we return to the rectification register and open the second image. And we start with point 1006. After the first 2 points, we are again given the approximate position of the remaining points. And if a yellow point lays near your measured point, the program will adopt its number automatically, and you only have to apply. We start the calculation of the transformation parameters, and you see that the program cannot calculate the residual error with only 4 points. We select the user-defined profile and adjust the scale to 1 to 25, start rectification, and load the image into the project. We can switch it on and off under image layers. For the next part we load coordinates we have measured with the total station. We select the control point class, and here in the tool window we can load a coordinate file. Under mapping training, image rectification, search CAD coordinates. We find this text file with the coordinates. You can create your own format for this CAD file. We open it. Click on import and get a list of all coordinates found in the file if were measured with the total station. Apply. The blue points you can see are those measured with the total station and are now added to our project drawing. You see them numbered with 9000, 9001, 2 and so on. Back to rectification, we open the fourth picture. And start with the points we have marked with the black and white crosses. Select the tool for automatic measurement of such markings. With pressed Shift, we switch to measure mode and draw a window. The program catches the center of the control point automatically. We give it a number, 9000. We measure the next point. After 2 points, the software again calculates the position and takes some number automatically. And in case the software cannot read the marking because the image resolution is insufficient, you can just measure it with the usual manual measuring tool to add these points. We start the calculation and take a look on the chart. We have now a much longer list of points we could use. With the filter show only coordinate path, we can narrow it down. All other points will be switched off and only the points used for the calculation are displayed. In this column we have listed again the residual error. And this time we have a range from 1 to 6 millimeters. The accuracy of control points is far better than of natural points. You can measure it correctly with the total station and have a higher accuracy with the automatic measurement of these control points. And therefore the result is far more precise than the rectification with the CAD file. Start the calculation. Adjust the scale to 1 to 25. Rectify the image and transfer it into our project. Search for the points 9004 and 9011 and return to the rectification tree. Load the third image. First we measure control point 9004 and then point 9011. We deactivate the filter show only coordinate pairs and are shown all remaining points already measured in other pictures. This way we can measure the next few points. Alright, that's enough. We start the calculation, activate the filter for coordinate pairs again, and take a look at the residual error statistic. Don't forget to set the scale to 1 to 25, and we start the rectification. Say transfer to map. Now we completed the rectification of our 4 images. If you have the time, load the remaining images out of the folder and try the rectification for the whole project on your own. We'll take it to the next step and work on the differences between the pictures. You can see the differences in colors, depending on the light. Therefore we will make a TIFF file export for a multi-layer TIFF file that you can open in Adobe Photoshop, where you can make the color corrections. We will do this in Adobe Photoshop to gain the best quality for your result. Over Project, Export, Assembly Layers, Multi-layer TIFF. On the left you have listed all image layers and can activate or deactivate them. In the preview you can also see the CAD file. You can activate the drawing over the Register Card project or deactivate the control points. We adopt resolution and scale of the project, and for the whole plane we are given size in pixel and centimeter right below. And the size of the picture will be nearly 1.5 GB. I think that's way too large. Therefore, we will cut the area down to a smaller section of the picture. We select the cutting tool and can now select with a rectangle the area to be exported. We You see the new selected area and the reduced size in pixel and in file size. And now we can say export. We create a new folder in the project and change the path. Create a new folder. We name montage wall north. And the resolution 04 and the scale 025. Open it and edit the name to north 04 and 025. Okay. In the first step, the software is now writing for each image layer a single TIFF file on the size of the selected area. And after all images are saved in the folder, they will be combined to a multi-layer TIFF file. The program does this in 2 steps because sometimes you have a large montage project and have to check the size of each picture. If the multi-layer TIFF is larger than 2 GB, older versions of Adobe Photoshop will have problems to open the file or claim that the image size is incorrect. That is wrong, but Adobe Photoshop is unable to work with it since they have a special format for files in this size. Because of this, you will have to wait for the writing of each single file. And as you see in the second step, the creating of the multi-layer TIFF. For this process you have to wait 1 or 2 minutes, but with large files up to 10 or 20 minutes. Meaning you can start the image file export and take a break to grab a cup of coffee. Okay, the program has written the TIFF file and we can close the dialog. But you can save the settings if you wish to use the same selection for further exports. We will do that. Name it wall north. Okay. And then we close the dialog and confirm to use them as standard options. Now we switch over to Adobe Photoshop. We open the multi-layer TIFF. I'm having training or north. And we find here our TIFF files. We see our image layers for the control points, the CAD file, and for each image rectification. And at last the multi-layer TIFF. We open it. And have listed all image layers. You could switch the layers positions. Could use the cutting functions. I believe you know the program well enough. You can change the colors, forms, etc. If you are finished with the picture editing, you can reduce the multi-layer TIFF file to one image layer, Save it and load it back into Metigo map under a new project and read it in for mapping. I show you how. The image reduced on one plane. Save it. I apologize that my version of Adobe Photoshop is in German only. We close Adobe Photoshop, and to load the image now, we click on Image Layer, right mouse click, and load rectified measured image. As always, under Mapping Training, Wall Off, Montage, and select the new file. We are asked for scale and resolution, and the software remembers the position in the paper area. Okay. You can deactivate the single rectifications and the CAD drawing, and our image is shown. If desired, you could switch off the control points and CAD lines in Adobe Photoshop, so only the rectified wall remains. Alright, that's all.